for is on writing linear equations. Okay, so we're going to go a little bit, like a step further than what we did last time. Okay, so slope-intercept form, that's what you guys probably all remember from Algebra 1. So that's y equals mx plus b. So y equals mx plus b. All right, m is the slope, and b is called the y-intercept. Okay, so let's write the equation negative 4x plus y equals negative 1 in slope-intercept form. Okay, so we're going to try to solve for y. That's why we did that in chapter 1. All right, so I'm going to add the 4x to both sides, add the 4x. And I want it to be y equals the x part first, so I'm going to have 4x minus 1. So when it's set up like that, you can see that your m is 4, right? That's your slope. You can think of it as 4 over 1 if you want. A lot of people like to think of it like a fraction, so you can see rise over run. And then the negative 1 is your b value. That's your y-intercept. So whenever you graph a line, you always have to have a starting point, and that starting point is not 0, 0. Like a lot of people always start at the origin. Okay, your starting point is your y-intercept, so you have to go up to negative 1 first, or down negative 1, so it's right there. All right, and then your slope is 4 from there, so you're going to go up 4, right 1. We want it to be positive in the end, so as I read from left to right, it's going to go up. So I'm going to go up 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1, right, and then draw a nice straight line. You could also go down 4, left 1, just as long as your line in the end rises when you go from left to right. Okay, so same thing for this one. So now you have x plus 3/4 y equals 6. So I want to get the y by itself, so I'm going to subtract the x from both sides. So I get 3/4 y equals negative x plus 6. Right, I put the x part first. All right, then I need to get rid of 3/4. So you can do it in 2 steps or 1 step, it doesn't matter. Some people like to multiply by the 4 first and then divide everything by 3. Or you can multiply everything all at once by 4 over 3. So when you do that, if you have 4 over 3 times 3 over 4, it becomes 1, right? 12 over 12, which is 1. So that just becomes 1y, so y. But you have to multiply it into each piece of the equation. So you're going to have 4 over 3 times negative x, so you're going to have negative 4 over 3x. And then you have 4 over 3 times 6. So off to the side, if you need to do 4 over 3 times 6 over 1, that's fine. You get 24 over 3, which is 8. Or you can reduce down. So you get 2 and 1, so you get 8 over 1 stuff. So 8. All right, so then we graph it. So your y-intercept is 8. All right, and your slope is negative 4/3. So now it's going to be going down. Caleb, did you forget your notes today? Or your notes in your locker? Do you need to go down? Okay. All right, so I have negative 4/3. So 1, 2, 3, 4. 1, 2, 3. Like that. All right, so I'm guessing that's the part that you guys were pretty good at on your homework. You understood that, you remember that. All right, so now it's a little bit more complicated because now we have 2 points. Okay, so it says draw the line through the points negative 4, 0, and 4, 6. So the drawing part's pretty easy. I think you guys can get that. So negative 4, 0, so 1, 2, 3, 4. That one's an x-intercept, right? Not a y-intercept because it's not 0, comma, a number. All right, and then 4, 6. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Let's go to that line right there. Now, when you're actually drawing the graph, you can count the slope, right? So you can always do rise over run. So you can talk about how much you rose from the first point to get to the second point. So you went up a height of 6, right? From 0 to 6. And then you went over 4 and then another 4, so 8. So your rise over your run is 6 over 8. And it's positive, right? Because it was rising when you went from left to right. All right, so your slope is going to be 6 over 8, which is 3/4. All right, and then you can try to find what the y-intercept is. Mine's a little bit off, so I can't really tell. But maybe you could say, oh, well, 6/8, that's the same as 3/4. So if I go up 1, 2, 3, and over 1, 2, 3, 4, you should be at that point. All right, and what that point is 0, 4. So it looks like your b value is going to be 4. And then you put it all together. So you have your y equals mx plus b. So m is 3/4 and b is 4. So y equals mx plus b. So y equals 3/4 x plus 4. Oh, is it 3? Can I not see it? Oh, it is 3. Thank you. All right. This value is 3. Yeah, you went up 3 over 4, right? So it should be 3. Okay. All right, so I got all of that from the graph. Okay, but sometimes you're not going to be able to just draw the graph. Sometimes I'm going to give you really crazy points, like 1,000, 7, or -50, 42, right? You don't want to graph those points. Okay, so you have to learn the method. So let's do the method without using the points. Like, pretend I don't have a graph. And all I was given was -4, 0, and 4, 6. Okay. So if I don't have the graph and I'm just given 2 points like that, you always need to know what m is. That's your first step, always. So we can find m because we know the slope equation. So it's y2 minus y1 over x2 minus x1. So it's 6 minus 0 over 4 minus a -4. So 6 over 8, which is 3/4. Okay, so we get the slope the same way. All right, and then we know we want y equals mx plus b, and we now at least have m, but we don't have b. And you never just want to plug something in for b unless you actually have a point that's in the form 0, a number, right? So that's the only way you know it's a y-intercept. You can't just say, oh, I have 4, 6, so I'm going to plug in 6 for b. You can't do that. 4, 6 is not a y-intercept. All right, so you can plug in any point in for your x and y, though. So any point on the line will satisfy that equation. So you can plug in x is 4 and y is 6. So you get 3/4 times 4, so 3. Oh, whoops. 6. So 6 equals 3 plus b. Subtract 3 from both sides, so you get 3 equals b. And then put it all together. Now you have your m, you have your b. So your equation is y equals 3/4 x plus 3. And that's it. Okay, so when we did it that way, we used the slope formula, which was the y2 minus y1 over x2 minus x1. You could do delta y over delta x, or you could just do the rise over the run, right? If you had the graph, just count the rise, count the run. Rise over run. All right, so it says find the slope of each line. Okay, so if we have the line through -1, 1, and 2, -5, right, so we just find the slope. So change in y over change in x. So it's going to be m equals -5 minus 1 over 2 minus a -1. Okay, so if you need to write x1, y1, x2, y2 underneath the points, that's fine. A lot of people do that. Okay, so you get -6 over 2 plus 1, which is 3. So you get -2. So your slope is -2. All right, you could do the same thing here. You could see that you have a constant slope if you want. Like, see how they're all adding 4? These ones are all subtracting 3. Let's see. So that means your slope is the change in the y value over the change in the x value, so -3/4. Okay, if you didn't know how to do that, if you didn't know how to find the change for each one, just go ahead and pick any 2 points. Like if you pick the first point, 4, 2, and the second point, 8, 5, and then find the slope, it's going to be 5 minus 2 over 8 minus 4. And you see how you get 3/4 as well. Well, negative. Let me think. What did I do? 5 minus 2, 8. What did I do? This first one. Oh yeah, you are adding 3. What am I doing? plus 3. Sorry, I went to Denver this weekend and got home at like 1:30 in the morning. So, Dragon, you guys are going to get bonus points. Who was that? Lily? Lily's got a bonus point too. Man. Now you guys are going to be on it. All right, so the next one. So the next one, we just have a vertical line. All right, so if you picked any 2 points on the vertical line, let's say we had 1, 2, 3, 4, 5, so 5, 0, 5, 1, you could do it that way. And your change in y over change in x would be 1 minus 0 over 5 minus 5. So you get 1 over 0. Right? Don't get confused and say this is 0. My calculus students still do this sometimes, where they're like, oh, 1 divided by 0, that's 0. That's not 0. 1 divided by 0, we don't know what it is. All right, it's undefined. All right, so this slope is going to be undefined. Remember my ski story? Did you guys think of that? Undefined. Words cannot describe this hill. Good. All right, next step. So it says another formula is very similar to the slope formula. However, it's used when you only have a point and you have a slope. Or if you have 2 points, you could use this one. All right, so this is called point slope form, and it looks just like the slope formula, only the denominator's been multiplied over. So it's going to be y minus y1 equals m times x minus x1. Okay, so basically it's similar to y2 minus y1 over x2 minus x1 equals m. It's just this bottom, this x2 minus x1 has been multiplied over. And the x and y we don't write as x2, y2 anymore. Okay, so they're really similar. So if you forget, you can always kind of think, oh, it's related to the slope formula. All right, so a lot of people are like, well, why do I have to know this formula? Like, obviously, y equals mx plus b works for me. Okay, if you take classes later on, most classes prefer this formula, this point slope form. And in calculus, if you take the AP exam, they actually prefer this form. So if you get something in the form like y minus 2 equals 3 times x minus 1, and then you go further and you try to simplify, and you're like, oh, I'm going to have this, and then you just do a dumb mistake because you're in this terrible AP test and you're like really stressed, and you're like, oh, negative 3 minus 2, I get negative 5, and you make a mistake, right? That shouldn't be negative 5, that should be negative 1. You should add 2 to both sides. You missed the entire point for the problem because you had it correct here, but then you simplified and got it wrong. So this is why you want to learn this form. So eventually when you use it in pre-calc and calculus, it's kind of a shortcut. You don't have to simplify further. All right, so it says find the equation of the line through negative 2, negative 3, and 2, 5. And it says write your final answer in slope-intercept form. So let's do it the first way, the way that you guys are used to, with just using y equals mx plus b. All right, so the first thing we do is we find m. M is the slope between these 2 points. I'm going to call it x1, y1, x2, y2. So I'm going to have 5 minus a negative 3 over 2 minus a negative 2. So I get positive 8 over 4. So I get 2. All right, so I have my slope. I need my b value. So when I look at those 2 points, neither one is 0 comma something. Right? If it had been like 0, 7, that's your y-intercept. Because if you think about how to plot 0, 7, you go over 0, up 7, it's along the y-axis. But I don't have anything in the form 0, comma something. So I need to find this y-intercept. All right, so I'm going to do y equals mx plus b. So I know I can't plug anything in for b yet. Okay, so I'm going to plug in my point. Either one. So let's plug in 2, 5. It looks easier, not as many negatives, right? So I'm going to plug in 2 for x, 5 for y, plus my b. So I get 5 equals 4 plus b. So b is equal to 1. Okay. The biggest error people do with this method is they think they're done at that point. They're like, oh, I found m and b, I'm done. All right, but that's not what I asked for. I asked for the equation of the line. All right, so I will count you off if you just find m and b and you don't give me the final answer. Your final answer is the actual equation of the line. Y equals 2. X plus 1, right? Y equals mx plus b. So that's what I'm looking for, the equation. Okay, so let's do the second way with the point slope form. So the m part's the same. You would find m the same way. So you do 5 minus a negative 3 over 2 minus a negative 2. So you'd still get 2 for your slope. But then you would know, oh, I have the slope and I have a point. So when you have a point and a slope, then you can use this point-slope form, right? They all make sense. Slope-intercept if you have the slope and the y-intercept. Point-slope if you have a point and the slope. So I'm just going to write it out. So I'm going to say y minus y1 equals m times x minus x1. All right, so m is 2. And x1, y1 can be any point that's on the line. So again, let's try to use the simpler point, this 2, 5. So I'm going to have x minus 2, and I'm going to have y minus 5. Okay, and then let's just simplify for y. Okay, so I'm going to have 2x minus 4. And then I'm going to add the 5 over, so I get 2x plus 1. And that's your final answer in the end. So what I was saying is, like, in calculus, you just leave it like this. That's why we learn this form. It's kind of nice. You can just leave it like that. But in Algebra 2, I do want you to go ahead and simplify to this form, because that's the form we graph with. So that way you guys are kind of knowing what the graph is looking like. Okay. All right, does that make sense? You guys think you can handle one? All right, so try this one. So it says, write the equation of the lines with the given characteristics. So part A says the slope is negative 3 over 2, and you're going through the point negative 6, 4. So go ahead and try that. Try A, B, and C if you can. All right, so let's try the first one. So your slope is negative 3 over 2. So right away we know that's your m. So m is negative 3 over 2. And then we have a point. So since we have the point and the slope, we're going to use this point-slope form. And I want you to start getting used to it. So I want you to try to use it if possible. If you get totally stuck on the test and don't remember how to do this, then yeah, just do the y equals mx plus b. You can always do that instead. All right, so your point is negative 6, 4. So that's going to be your x1, y1. So you're going to have y minus 4 equals negative 3 over 2 times x minus a negative 6. Okay, so that ends up being plus 6. All right, so you're going to distribute your negative 3 over 2. So it's going to go into both pieces. So you're going to get negative 3 over 2x. And then off to the side, if you need to write this, you have 6 times negative 3 over 2. It's 6 over 1. You can multiply across the top and the bottom and then reduce, or you can reduce before you multiply. Either way, so I get negative 18 over 2, which is the same as negative 9. Do you see how if you had reduced and made that 6 over 2, made it 3 and 1, you'd also get negative 9. Same thing. All right, so I get negative 9. I have y minus 4, so I want y equals in the end, so just add the 4 over. So you get y equals negative 3 over 2x. When you add the 4, you have negative 9 plus 4, so minus 5. So that should be your answer. So how many of you guys got that? A lot of you. Good. All right, so this next one's a little bit different. Okay, so this is what Zach was saying at the beginning of class. He was like, you know, I got most of them on the homework, except I'd forgotten how to do this one. Okay, and these are the ones that people usually have trouble with on the test. Okay, so it's through the points 1, 5, and negative 2, 11. All right, so we don't have the slope. So it makes sense. I can't do slope-intercept right away because I don't know the slope. I can't do point-slope right away because I don't know the slope. So I have to find slope first. I need that. So I have m equals y2 minus y1, so 11 minus 5 over x2 minus x1, negative 2 minus 1. Okay, so I get 6 over negative 3, so I get negative 2. Okay, so now I have the slope. So think about what else we have. We don't have the y-intercept because I don't have 0 comma anything. All right, so I have to use the point-slope form. Well, I don't have to, but I'm going to use the point-slope form. So I have y minus y1 equals m times x minus x1. So I'm going to pick either point. I usually pick one if it doesn't have negatives. I'll pick that one. I don't like all the sign clutter. To me, minus the negatives. All right, so I have y minus 5 equals negative 2 times x minus 1. Distribute your negative 2. So I'm going to have negative 2x plus 2. And I'm going to add the 5 over. So I get negative 2x plus 7 in the end. So that's your next answer. Okay, here part C is a hard one. Did you guys get fractions for part C? Oh, fractions. By the end of Algebra 2, I'm going to make you love them. You're like, oh, fractions. Woohoo. All right, through the points 2, 7, and 5, negative 4. All right, so my slope is going to be y2 minus y1. So negative 4 minus 7 over 5 minus 2. So I get negative 11 over 3. Oh, man. Negative 11 over 3, that's just not pretty. We're going to go with it. All right, so I have my slope and I have a point, right? Either one, so we'll use the 2, 7. So I have y minus y1 equals m times x minus x1. So my slope is negative 11 thirds. I have x minus 2. I have y minus 7. And I didn't have to use 2, 7. You could have used the other ones. So when I say x1, y1, I use it pretty lightly because it could have been what you originally had as x2, y2. It doesn't really matter. All right, I'm ready to distribute. See why in AP Calc it's nice to just leave it like that? And you don't do all the extra work that I'm making you do. That'd be nice. All right, so I'm going to distribute. Okay, so I have negative 11 over 3x, and then I have negative 11 over 3 times a negative 2. So I get 22 over 3, right? Okay, so I'm going to have plus 22 over 3, which I like the improper. I like you to have the improper fraction instead of a mixed number. All right, last step. We need to add the 7 over. So I'm going to add 7, add 7. So I have negative 11 over 3x plus, I have 22 over 3 plus 7. Okay, remember I need to get common denominators. So what am I going to rewrite 7 as? 21 over 3, exactly. You guys remember that? Common denominators. So it's like you took the 7 over 1 and you multiplied by 3 over 3 to get 21 over 3. So I'm adding 21 over 3. So I get 43 over 3. And that's your final answer. Did anybody get that one? Yeah, a couple of you. Good. All right. Let's try this one. So it says in the game of Monopoly. Did you guys ever play Monopoly? That's still a thing? Okay. I love Monopoly. I used to cheat when I was little. Did you guys cheat? I always stole money from the bank.
No, my dad was running.
All right, so it says if a player lands on a property owned by someone else, they must pay rent. And this rent is actually modeled by a linear function of the selling price. So it's related to the selling price, which makes sense. You guys remember that, like Boardwalk, it was always really expensive to buy it, but then when people landed on it, you got a lot of money. So it was exciting. All right, so express the rent as a function of the selling price. So when you say function of, okay, the thing after it is x, right? Y is a function of x. Okay, f of x. All right, so rent is going to be y. So selling price is x, rent is y. So we need to come up with our rent equation, so our y equals equation. Okay. So I can pick any 2 points that I want. It doesn't have to be all of them, just pick any 2 points. I'm going to guess I want to use the point 60, 2 because it looks simple, and 100, 6. Easier numbers, right, than the other ones. All right, so I'm going to come up with a slope between them. So I'm going to have m equals y2 minus y1, so 6 minus 2, over x2 minus x1, 100 minus 60. And make sure you're doing y's over x's. Everybody always messes that up and does x's over y's. Change in y over change in x. So you get 4 over 40, which reduces to 1/10. So your slope is 1 over 10. All right, so we have the slope. We don't have the y-intercept because I don't have any points that are 0, a number. Okay, so I'm going to use my point slope form. So y minus y1 equals m times x minus x1. I have my slope. Use any point. What point do you guys want to use? 60, 2, right? Smallest numbers. So let's use 60, 2. So x minus 60. All right, and then y minus 2. Okay, so I'm going to distribute my 1/10. Multiply that in. So I'm going to get 1 over 10x minus, you have 1 over 10 times negative 60 over 1. Do you guys see you get negative 6? right? Negative 60 over 10, which is negative 6. All right, so I have y minus 2. I'm going to add the 2 to both sides. So you get y equals 1/10 x minus 4. That's your answer. Okay. So it says, well, how much would be the rent for Illinois Avenue then, which has a selling price of $240? Okay, so now you're going back. If the selling price is $240, is that your x or your y? The x, right? So we said selling price was x. So we're going to use that equation, the y equals 1/10 x minus 4. And we're going to plug in x equals 240. Right? And then that's going to find the y value that's associated with that price, the rent that's associated. So I have 240 over 10, which ends up being 24, right? 240 divided by 10. Minus 4, so it's 20. So the rent for Illinois Avenue would be $20. Is that the last one? Yep, one more. All right. So the next thing we're going to talk about is parallel and perpendicular. So I kind of gave you a preview last time of parallel and perpendicular. Remember, parallel lines have the same slope. Perpendicular lines have opposite reciprocals. So if my slope is 2/5, so 2 over 5, what's my perpendicular slope? Negative 5 over 2, right? Okay, what's my parallel slope? 2/5, right? Same. All right, so let's try these. So it says write an equation for the line that passes through 3, negative 2, and is perpendicular to the line whose equation is this. All right, the only thing I get from the part where it says perpendicular to this or parallel to this is the slope. That's all I care about. Does this make sense? Because I have lots of lines that are perpendicular to the same line. The only thing I'm getting is the slope. All right, so I have y equals negative 5x plus 1. So what's your slope there? Negative 5, right? So if I say perpendicular to that, my new slope is m equals, right, flip it. So think of negative 5 over 1. So it's going to be 1/5. Instead of being negative, it's now positive. So the sign changes and it becomes the reciprocal. So my slope is going to be 1/5. That's the only thing I get. So we only use slope from this. Okay, a lot of people get confused and they're like, oh, I'm going to use that plus 1 too, that y-intercept. It doesn't matter where it crossed the y-axis. Like I said, there's lots of lines that are perpendicular to the same line. All right, so I have my slope. I have a point, so I'm going to do my y minus y1 equals m times x minus x1. Okay, and I'm using this point 3, negative 2. So my slope is 1/5. I have x minus 3, and I have y minus a negative 2. So I get y plus 2 equals 1/5 x minus, off to the side, if you need to do 1/5 times negative 3 over 1, you get negative 3/5. So I have negative 3/5. Now I'm going to subtract 2 from both sides. So when I subtract 2, subtract 2. So now I have 1/5 x. I have negative 3/5 minus 2. So how can I rewrite 2 to combine them? Yeah, so we want 5 as our denominator, right? So I want negative 10 over 5. So I'm going to have negative 10 over 5. So I get negative 13 over 5. Does that make sense? And that's your equation. So that is the line that goes through that particular point, and it's also perpendicular to that original line. Okay, you can try the next one. So it says write an equation for the line that passes through negative 4, 8, and is parallel to the one whose equation is this. Now notice my equation is 2y equals x plus 10. My slope is not 1. You see how when you look at it, a lot of people are like, oh, the number in front of the x, it's 1, so my slope is 1. Right? It's not in y equals mx plus b. It's 1/2, right? Does that make sense? So get it in y equals mx plus b, find the slope, and then work from there. I'll let you try it for a sec. All right, so the first step was to take this original equation, so the thing that we're going to be parallel to, and solve for y. So I have y equals, you divide by 2 everywhere, So you get 1/2 x plus 5. Okay, so that's your original equation. The only thing you get from these original equations is the slope, right? Because I said parallel to this. All right, so my original slope was 1/2, so my new slope is also 1/2, right? Because it's parallel. Did you guys write -2? You got 1/2? All right. So now I have a point, -4, 8. I can't just plug in 8 for b. It's not the y-intercept, right? So I have y minus y1 equals m times x minus x1. So my m is 1/2. My x1 is -4, so x minus a -4. Y minus 8. So I get y minus 8 equals 1/2 x. This is really plus 4 because we have two negatives. So half of 4 is 2, so plus 2. Add the 8 over and you get y equals 1/2 x plus 10. That's your answer. All right, so I'm guessing the next one's going to involve some fractions. Let's try it. So it says write the equation for the line that passes through -1, 7 and is perpendicular to this. So if it's perpendicular to 2x minus 3y equals 6, I first need to solve for y. To see what my slope is. So I can't tell. Like, it's just not 2, right? A lot of people think just in front of the x, but it's not in y equals mx plus b form. So subtract your 2x. So I have -3y equals -2x plus 6. Divide by -3. So I get y equals 2/3 x minus 2. So I did that pretty quickly. See if you guys understand. So I got the 2/3. So it's -2 divided by -3. So positive 2 over 3. So basically this -3 went into both pieces here. All right, so that means that my slope is 2/3, but I want it to be perpendicular. Okay, so what's my new slope then? -3 over 2. So my new slope is m equals -3 over 2. All right, we're going to use that new slope with this original point, this -1, 7. So I'm going to have y minus y1 equals m times x minus x1. So I have -3 over 2 times x minus a -1, so x plus 1, really. Y minus 7. So I have y minus 7 equals -3 over 2x. Like I said, this all becomes plus 1. So 1 times -3 over 2 is -3 over 2 still. All right, and then we have to add this 7. Oh, man. Okay, think of your common denominators. So I'm adding 7, and my -3 over 2 has a denominator of 2. I want it to have a denominator of 2. So I'm going to have y equals -3 over 2x. I have my -3 over 2, and I'm adding 14 over 2, right? That's the same as 7. So I get y equals -3 over 2x. And then -3 plus 14, so plus 11 over 2. And that is your final answer. All right, so I went through that last one pretty quickly. Hopefully you guys understand.